Good afternoon, and thanks for joining the call. I'm Paula Biskup, Global Marcom Manager for Trinseo's Performance Plastics Consumer Essential Markets business. During the next hour, we're going to talk about reducing the risk of non-compliant lighting applications by pre-selecting plastics. This topic is something we felt could be of value to the marketplace. For those of you who aren't familiar with Trinseo, we're a global materials company, a supplier of plastics, latex binders, and synthetic rubber. We provide high-performance plastics to a number of industries, including lighting, where we provide polycarbonate-based blends for various applications, such as bulbs, tubes, lenses, reflectors, all the way to complete luminaires for both indoor and outdoor use. We've been working with the lighting industry since really the start of the evolution to LED technology, so we have a pretty firm foundation in the lighting space. I want to start off right now by introducing you to our presenters. First, we have Bill Marshall. He's a colleague at Trinseo, and he's responsible for the lighting business at our company. He'll start off by giving you a perspective of what he's found in the marketplace, which was really the impetus for this event. Next, we have John Allen. John's the founder and president of Product Safety Consulting. With over 31 years of experience, John is recognized for his expertise in lighting, medical, and industrial controls compliance standards. PSC has provided expert advice and testing services to over 3,000 companies in 35 countries since 1988. And as I said, I'm Paula Biskup, also from Trinseo. The lighting sector is one of the markets we support, and regulatory issues are something we always need to be apprised of since it's a concern of our customers. Trinseo, like Product Safety Consulting, works with compliance issues daily, and we recognize the challenges in the marketplace. We hope that this webinar is insightful and clarifies a few points for you. Now I want to begin by turning the floor over to Bill Marshall, but before I do, I should mention that while we'll be holding questions until the end, please feel free to submit your questions throughout the presentation by using the question field at the bottom of your screen. So now let me turn it to Bill.
Thank you, Paula, and thanks everyone for joining us today. I'm going to give a very brief introduction before turning it over to John. I'll start out with, the emergence of LED lighting as a dominant light form in virtually all lighting applications comes with that comes many challenges and opportunities, not only for the LEDs themselves, but also for materials used in LED lighting fixtures. As you all well know, LEDs offer high efficiencies, the long lifetimes, and since they're solid-state devices are very durable. They also offer new design freedoms to engineers and designers, and freedoms and options that were not available with historical light sources. So materials used for lighting have changed with the evolution of the LED technology. Plastics such as polycarbonate and acrylic are commonly replaced in glass and lenses and optics, and also in metal, replacing metals for housings. Plastics offer many potential benefits, including design freedom, reduction in processing steps, cost savings, improved break resistance, reduction in part weights, just to name a few. But they also offer challenges in terms of heat resistance and ignition resistance. So not all plastics are capable of being used for lighting application, and not all materials are for that end. Understanding when it is appropriate to use plastics and what are the requirements and regulations that must be met, what materials are acceptable, becomes very critical to understand. And to help us understand the regulatory requirements for LED lighting applications and the process for achieving regulatory compliance, I'll now turn it over to John Allen, who's the president and founder of Product Safety Consulting. John, it's all yours.
Thanks a lot, Bill, and welcome everybody to the webinar. I'm John Allen, as Paula and Bill indicated. Been doing compliance for the better part of 31 years now. Lighting has always been part of our work. So we've come and seen the LEDs. all the new requirements, UL 8750 and 1598. So very well versed in lighting compliance, which allows us to partner with Trinseo on this webinar, and we're very happy to do that. What we'd like to start with actually are a few polling questions. What really caused you to be interested in this webinar? So we get an understanding of why you're here and how we can help. As a designer, you're interested in regulatory issues or testing for polymers. You're interested in how regulations might impact your purchasing, or you're a manufacturer and you sell polymers and you want to understand some of the requirements for enclosures and polymers as it relates to lighting. We see this is compliance can many times be an issue, and actually we see as consultants designers and companies that don't read the standard ahead of time. You're going to end up with some non-compliances. 9 out of 10 products fail the first time through, and it really can screw up your timing on your product launches, get you back into a development or rework type process. Acceptance of the marketplace can certainly be hindered if you're late to deliver, and of course overall profitability could be hindered as well. Okay, I lost my ability to move the slide. Hang on. Paula, can you move the slide?
There.
Sorry about that, folks. A little technical difficulty. Areas, this is regardless of the construction, regardless of actually the industry, a lot of non-compliances occur over these common areas. Overall construction doesn't comply with the requirements. Enclosure materials, we see a lot of people using the wrong materials, which is one of the main reasons for this webinar. When you cut steel, you want to make sure you're cutting it correct for the correct material. Portable versus installed and permanently mounted has always caused a bit of confusion in the industry. Creepage distances, dimensional stability, clearances, and electrical spacings are a common area we see non-compliances. Incorrect components, even though they're UL certified components, they may or may not be used within their ratings or conditions of acceptability that we'll be talking about. We also see power cords being used incorrectly. Outdoor cords need different ratings than indoor cords, and depending on how much current you have, will determine the appropriate cord. So why do we get our products certified? This slide here, if you look in the middle section, acceptable, this is from our Federal Register regarding OSHA, Occupational Safety and Health Administration. Acceptable for workplace safety, products have to be listed, labeled, or otherwise determined to be safe by a nationally recognized testing laboratory, NRTL. Without an NRTL mark, the local authority having jurisdiction, we call it the AHJ, could actually red tag an installation and not accept your products installed for that particular building. Initially, and actually, so the OSHA requirements used to state, instead of NRTL, Nationally Recognized Testing Laboratory, it stated UL. And Leonard Fryer, the owner of Met Labs, actually took OSHA to court, and in 1988, as you saw, the Federal Register is when our regulations have changed. So initially, the marks for certification here in North America were the CSA mark up in Canada, and then UL for the U.S. Now with NRTLs, We have a bunch of different laboratories. I think we're up to 17 at this point in time that can issue a certification mark that's accepted here in the States. And then also these NRTLs also have submitted to the Standards Council of Canada to be able to issue their mark in Canada. You can see the MET mark with the small c to the left and then the US to the right. That means MET Labs evaluated the product to both Canadian standards and the U.S. standards. And the U.S. standards are written by UL. We're not going to go to these links, but I did provide them in the presentation here for you to have access to. Please go there. These are the links to define the NRTL program by OSHA. Very useful website. So types of certifications, we're going to use the UL mark for this slide here. So listing mark is the UL mark in a circle or one of the other NRTL marks in the circle. That's for an end product. That means the product can stand alone and not need some kind of enclosure or some other condition of acceptability. The famous backwards UR mark means it's a component. That means there's some sort of conditions of acceptability that have to be met for it to be used. For example, a 2-amp switch that you all recognize has to be used in no more than a 2-amp circuit. And that component also probably has to be enclosed. That would be another condition of acceptability. UL also, and sort of the other NRTLs, also issue what we call a classification mark. A good example is you can actually go to UL or MET or ETL and ask them to issue a mark that states you comply with one of the IEC standards, for example. That would be classified versus listed. And then we have unlisted components which don't have any marks but are custom components in your device that you want to test to be covered for your device only. It would be a full set of tests. You don't get to sell it as a recognized component, but you use it in your end device. Today, the international landscape, we're trying to get harmonized. Don't kill the messenger, but we're not there yet. Lighting, the main standard, 1598, is actually harmonized with IEC 60598, but the driver standard, the 8750, is not harmonized. We also are showing on this next slide all the different marks around the world. Of course, for Europe, you've got CE, China, the CCC mark, Brazil is in Metro, India and Japan. Japan actually has 2 marks. The circle is for products that are voluntarily certified. The triangle are for products that are mandatory, and there's 2 lists in Japan that indicate what category you're in. A lot of the lighting products are in the voluntary, but there are certainly some that are mandatory. And then, of course, the other marks around the world. Harmonization, as I indicated, the lighting standards, not real harmonized at this point, even though 1598 and IEC 60598 are harmonized. 8750 and the IEC standard for drivers, 61347, are not harmonized at all. And back to 1598 and 60598, although they say they're quote-unquote harmonized, you still have national deviations within the IEC. So the U.S. Actually has several national deviations affiliated with the IEC 6598. The truest advantage, and we call it a CB scheme, it's a certification scheme, where the idea with the CB scheme is to get your product tested by one of the certified labs. Most NRTLs, UL, MET, Intertech, CSA, they're all in this program, and the idea is to test your products with one of them, and they've harmonized around the world with the other certification bodies. So the TÜVs in Germany, VDE in Germany, even the PSE mark, if you have, excuse me, so the idea is to test with one lab, get their certification, cover all national deviations for whatever other countries you're going to, and then when you go to that other country, let's say Germany, they want the GS mark, you can then submit your CB certificate to TÜV, for example, to issue the GS mark. And as long as you've covered all the German national deviations, there should be no or little additional testing to get that certification in that other country. These are the European standards for luminaires that we'll use internationally. The EN standards are exactly harmonized with the IEC. Most cases exactly. There's some minor differences with national deviations, but it's important to note that rest of the world other than the U.S. is harmonized to 6598. Components, we talked a little bit about components. I hear this daily. All of my components have a mark on them. I should have no problem getting listing. Well, the proof is in the pudding and the devil's in the details. All components, as I alluded to earlier, have what we call C of A's, conditions of acceptability. A bad example is, although the UL switch is 2 amps, if I put it in a 3 amp circuit, it's not certified, or it's not applicable even though it's UL listed. Another C of A for outdoor units, for example, if you're using an enclosure material that doesn't have a UV rating or water immersion rating, then it's not going to be accepted even though the material itself is UL. Another condition, we'll go into a little bit more detail regarding low voltage limited energy drivers, but additional testing is required on that component. The typical certification process, actually we use UL as an example, but pretty much any certification body is going to follow this process where we put together a request for quote, and the more detailed you are on your request for quote, the better. You have to indicate intended use, electrical ratings, properties, provide a sales brochure so they could see it as well. Get that into the certification body. UL, we do it online. CSA, we send to our contacts, salespeople. Then you get the quote. And it's important to look at the quote and make sure that the quote matches what you asked for. Nobody's perfect, and sometimes a standard might have been incorrect or whatnot. So certainly review the quote and make sure it's appropriate for what you asked for. Then you accept it, and you'll submit all of your documentation that they requested, examples and samples. Then once the project is open at the certification body, they will do their construction evaluation first and then put the product into the lab for testing. We want to make sure that we're testing a product that complies with the construction requirements. It does not make sense to throw it into the lab before knowing that. And of course, all certification bodies have a review process. You typically will see 2 signatures on an authorization to mark letter or a notice of completion. A lot of people don't understand item 9. If you've never made a UL listed product before, or an ETL certified or a MetLab certified product before, they're going to ask to come to your production facility before you ship out your first products with their mark on it. Doesn't mean you have to comply with ISO 9000, but you certainly are looking to show the inspector that you know how to do the production line testing and that you can build a unit that is actually described in the report. And then if IPI is required, listing is actually issued after that inspection has been successfully completed. These are, this next slide here, considerations for all parts. No matter what the product, these are a lot of the common things we see happening. where people are using friction alone to secure uninsulated live parts. Maybe a switch has some kind of friction lock on it, where the terminals are bare inside and you can turn it fairly easily without a tool. That's not acceptable. Believe it or not, we see people using metal enclosures with no corrosion protection. A lot of people we see using solder as a connection, where solder alone cannot be used as a reliable connection. Parts have to be mechanically secured before soldering. The only instance where solder can be used as a reliable mechanical means of connection is in a Class 2 or LVLE circuit, and we'll be talking about that later in the presentation. We see a lot of cabling without strain reliefs. If you have a cord-connected product, we're going to pull on that cord with 35 pounds for a minute, and we want to make sure we have no strain going to the connection inside the product. We see this is crossing low and high voltage connectors is unacceptable unless the low voltage conductor is rated for the line voltage that it's connected or in contact with. So your low voltage wiring going to your LED board, if it's in direct contact with one of the line voltage wires, that low voltage wiring has to be rated for 120 volts, or you physically separate it out. But that's a very common non-compliance that we see. We see cord and plug connected devices permanently mounted to a building structure. Well, that's not acceptable. If you're permanently mounted to a building structure, you cannot have a cord that's actually per the NEC. However, you will see some corded devices mounted on a wall if they have keyhole slots. If I could remove the product from the wall without a tool, then it's actually portable and a cord is acceptable. These are the different types of configurations we see for lighting. Some companies have a separate power supply, a separate driver, a separate array. Some put the power supply and driver together on one board with the array separate. Some have it flopped where it's the power supply, a mean well power supply, and then their own custom current limiting or what have you driver and array. And then, of course, we will also see all three on one board. So many different configurations we see with lighting. Class 2 power, really like to explain this to people because it gets you out of a lot. If you can have a Class 2 power supply, you see the definition there, 42.2 volts peak, 30 volts RMS, 60 volts DC, and you have to have less than 8 amps after a minute of operation. You need physical separation between primary and secondary. And if you do those two things, then your circuit on the output of that is considered no risk of shock or fire. I question the fire, and we'll talk about that in a minute. There will be no need, however, per the requirements, for an electrical enclosure. So if you have a Class 2 power supply and your LED array is connected to that Class 2 power supply, there is no need for an enclosure over that LED array. The requirements, no mechanical testing, no temperature testing. We will do temperature testing on Class 2, and that's where the confusion with fire. We say no risk of fire or shock, that's per the NEC, but we know LEDs get hot, so we will do temperature testing on even in a Class 2 circuit. However, they can be accessible. Wiring can be accessible. Less than 24 gauge wire can be used, reducing your cost. And then the lens over the LED, which is important, can now be a lower flame rating, 94 HB versus a V2, which is required for non-Class 2 circuits. If you don't have a Class 2 circuit, we can evaluate your circuit to be considered low voltage limited energy. The voltage and current limits are the same, so basically what we do is go through your circuit and find the point within the circuit that meets those voltage and current limits. Then you go one more step, and then that part of the circuit from there on is then considered low voltage limited energy. We will do component breakdown ahead of that to make sure that under single fault condition you still meet the voltage and current ratings to be considered LVLE. But again, your advantages are your enclosure over the LVLE circuit can be a lower flame rating. However, you still do need a barrier. So if you have an LVLE circuit, you still need some kind of enclosure. And there will be a push and pull test on that barrier, or enclosure we call it. If you're not Class 2 or LVLE, your enclosure, even over your LED, if it's not considered Class 2 or LVLE, your enclosure over the LED array, of course, has got to be a UL material. It has to be 94V2 now for portable, or 5V for permanently mounted equipment versus that 94HB. Big cost difference, and I'm guessing a big difference in the ability to let the light out. We still have to comply with the relative temperature index ratings. That's why we do temperature testing. There's going to be much more mechanical abuse testing on enclosures of non-Class 2 circuits. And if you're outdoor, you still have to have the UV rating and water immersion rating. The circuit itself, if it's not Class 2, every electrical component in there is going to be called out in your report. We will need voltage mapping so we can evaluate the creepage and clearances on the circuit boards from trace to trace. And we will also be breaking down components, shorting resistors, opening capacitors. There's just a lot more engineering evaluation to do. Doesn't mean it can't be done, but life gets a lot easier if you're Class 2. Enclosure materials for lighting. Of course, we see metal and plastic, and for metal, you usually have to have a certain thickness depending on the luminaire. You will need corrosion protection, and of course, the product will have to be grounded. For plastic, you're going to need flame rating, appropriate flame rating. The correct thickness we'll talk about in a minute. We'll show one of Trinseo's yellow cards. If it's in direct contact with live parts, you're going to need some electrical properties, CTI, HAI, HWI, and of course, if it's outdoor, UV rating. So here is one of Trinseo's yellow cards, we call them, in the UL Plastics component directory. You can see under flammability flame rating, this is a real good thing for designers to understand. The flame rating, if you look to the middle underneath value, at 1 millimeter thick is V0. Well, if you were permanently mounted to the building structure, you have to have a 5V rating. So you actually, if you were using this material, your thickness, overall thickness of that enclosure would have to be 2 millimeters versus 1 millimeter to be considered acceptable as a 5V flame rated material. Underneath the electrical properties, this is a good material if you happen to have uninsulated live parts in direct contact with the material. There's ratings in the standard that call out these different PLC levels. Based on the flame rating, it'll determine which PLC levels you have to have. If anybody has any other questions on that, we can certainly take that offline. It does get a little complicated. The thermal indexes, you can see RTI electrical and then RTI impact, IMP. They are lower. So under our normal operation testing, if this was an enclosure, we'd have a thermocouple, many thermocouples on the inside wall of the plastic trying to find the hottest spot, and they would all have to be under 115 degrees C for it to be accepted as a UL or NRTL certified product. More on, of course, polymeric enclosures. If it contains live parts, it's considered an enclosure. And we have to pass temperature testing. There's mechanical abuse testing as well, drop, ball impact, and crush. You have to be conscious of openings. There's a finger probe in the standard you may or may not be familiar with, but it's an articulating probe that we put in the openings to see if we can touch live parts. That cannot happen. So if you have a big opening, you put a barrier or you insulate it, or you have to make the opening smaller and then use more of them. If you're outdoor, of course, you have to be UV rated, and you must pass the water exposure and cold impact testing is required for outdoor products. And as I indicated, if you have uninsulated live parts within a 32nd of an inch, doesn't have to be in contact with, but if you're within a 32nd of an inch of a plastic material, that plastic material must have electrical properties. These are the electrical properties if you do need them: volume resistivity, dielectric strength, CTI, inclined plane, dimensional change after water exposure, heat deflection, Vicant softening, or ball pressure test is done. Resistance to creep, high current arc resistance, hot wire ignition, tensile strength, and of course relative temperature index. If you're outdoor, you also of course need to do some kind of water exposure on your luminaire. The material itself has to be UV rated and immersion, but you will be doing rain test or splash testing depending on the location of where your luminaire is outdoor. If it's a decorative part, you can get away with an HB flame rating. What does decorative mean? Decorative means that it's not enclosing any live parts. So if you have a part that's hanging off the end and it's not enclosing any live parts, it can be an HB flame rated material. These are the required tests. Typically for any luminaire, we're going to do an input test. Most standards say you can't exceed 100% of the marked rating, 110%, I'm sorry, of the marked rating. We're always going to do a temperature test. There are some exemptions. Fluorescent lights with a Class P ballast do not need temperature testing. Table lamps, if you comply with the construction requirements of a table lamp, i.e. your incandescent bulb that we don't sell anymore is a certain distance from the shade, that's a test exempt product as well. So make sure when you're reading UL 1598, if you want to be considered test exempt, there's a whole section that describes how to do that. We're always going to be doing dielectric testing. That confirms if there's any insulation system nicks and wires, sharp edges, whatnot, that are going to short the ground. Some kind of abnormal is going to be done. Output loading. If you have a motor or a fan in there, we're going to block the fan. Thermostats, we're probably going to short them. And hopefully you have a thermal limiting device there. For cord-connected devices, leakage current is always required. We want to make sure that the current leaking from the appliance to ground is under certain shock limits, 0.5 milliamps. Cord-connected devices, as I indicated, we're always going to do a strain relief. CSA up in Canada requires a push back. So do the IEC standards. Mechanical strength, impact, and ball testing is going to be required on enclosures. If you don't have Class 2 and you want your circuit to be considered LVLE, we have an engineering evaluation to do on your circuit. Environmental tests, of course, if you're damp or wet, will determine whether you do the rain or splash testing. Plastic enclosures also undergo a mold stress test. That's 7 hours in an oven at 10 degrees C, higher than the hottest temperature measured during the normal temperature test. And what we're looking for is, because all tooling and molds create stresses within the material. We want to relieve those stresses to see if it's going to cause a gaping hole or move spacings such that things will short out. If there's openings underneath solder connections or motors or terminal blocks, we're going to do a flaming oil test as well to make sure we're not going to start the supporting surface on fire. If you provide an outlet box, we're going to be doing the knockout and twist and weight and moment test on the outlet box itself. And of course, mechanical loading, if you're mounted to a wall, typically 4 times the weight for an hour to make sure the product's, there's no increased risk of shock or fire. Key points for our webinar today: always be certain the product will pass before you submit. Read the standard clause by clause. If you have questions, call somebody. UL, Intertech, they're pretty good about answering things. Of course, we are as well. Make sure all your components are recognized and appropriately suited to the end product. Don't use that UL recognized 2-amp switch in a 3-amp circuit. Make sure when you're talking to your suppliers for your critical components that you get those conditions of acceptability. They should have no problem giving those to you. It's not proprietary information. It's useful information for the designer to pick the right component. We actually do a webinar just on components, choosing them as well. So it's a critical thing. Class 2 and LVLE makes life a lot easier. If you can get a Class 2 power supply, I would recommend it. It will make your life, everything on the output of that, from a risk of shock and fire standpoint, is sort of mundane from a compliance standpoint. Anticipate the test program, do the testing ahead of time, and of course build in extra time. If the certification agency tells you 4 weeks, plan on 6. Those are some key points to remember.
Okay, thanks, John.
Yep.
We had a number of questions that came in during the presentation, just several. So maybe for you and Bill, if you can answer these for our guests today. First question, how do I know if a power supply is Class 2? And it sounds like you, John. Can you answer that?
So the only way to know it's Class 2 is if it's marked Class 2, and the number 2, not Roman numeral 2. It's very, very important. So anybody that tells you, oh yes, we have a Class 2 power supply, if it's not marked on the product with the words Class 2, the number 2, then it is not a Class 2 power supply.
Okay, thanks. Next question. I think this may be Bill. I'm a design engineer for a lighting OEM. I typically use aluminum as my material of choice for housing applications. It's inexpensive and inherently flame retardant. Why would I want to move to a plastic in its place?
Aluminum is less expensive on a per pound basis. Plastic material can quite often be less expensive overall for a couple of reasons. One, the density of plastics is far less than aluminum. So parts produced for plastics, such as polycarbonate, will weigh less by more than half of what the same part made from aluminum. So the cost per part will be less. And then secondly, aluminum requires additional secondary operations such as electrocoating and painting, and which add cost and labor, whereas the thermoplastics do not require the secondary operations. So quite often the thermoplastic choice is actually the more cost-effective choice compared to the aluminum.
Okay, thanks, Bill. Okay, this next question, I'm not sure if you or John want to go with it. For polymeric enclosures, if the material is F1 rated, Does the entire device need to pass water exposure and cold impact testing? What kind of cold impact testing is done, and is it a drop test?
Yeah, I can take that, Bill.
Okay.
So the F1 rating for materials indicates that it meets both UV and water immersion requirements, the material itself. So even though you have, that's the first step to an outdoor product, is use a material with the F1 rating. If you don't have an F1 rating on your material, there's no sense in even doing the outdoor luminaire testing. So first, you have to have F1 on your material, and then the end product, the luminaire, is still going to undergo the, not immersion, but water exposure test, either the splash test or the rain test. And then outdoor will also, depending on the location of outdoor, we do a cold impact. If you're under a canopy, it's 0 degrees C for 3 hours, and then 5 foot-pound impact immediately after. If you're outside of a canopy and truly outside, it's minus 35 degrees C for 3 hours, and then immediately after that, a 5 foot-pound impact. Drop test, don't believe drop test is required for outdoor products. I mean, drop after the cold environment. Hope that helps.
Okay. Last question we have. Can you give some common types of lights that are Class 2 and LVLE? If a light is not Class 2, does it mean that it's Class 1? And can you give some examples of portable versus permanent?
Yeah, boy, that's a really good question, and there's a lot of confusion in the industry that I see regarding that. So keep in mind the number 2 versus Roman numeral 2 are completely different things. The number 2, Class 2 with the number 2, is the risk of shock or fire we've been discussing. The Class 2 Roman numeral 2 means that the product is not grounded, it's double insulated. So it's an insulation system marking, not a risk of shock or fire marking. You do have Class 1, Roman numeral 1, Class 2, Roman numeral 2, and Class 3, Roman numeral 3, that are the insulation type classes, where 1 is grounded, 2 is double insulated, 3 is secondary extra low voltage, i.e. battery products. So please don't confuse Class number 2 with Class Roman numeral 2. There's a big difference.
Okay. Okay, those are all the questions we have for now. Let me put up the contact information. And thank everyone again for joining. And immediately following the close of this presentation, you'll receive a very brief 3-question survey, which John alluded to at the beginning. That's for our own market research purposes. So we'd very much appreciate it if you could take a couple minutes and just fill out that survey. And with that, I wish you a good day, and thanks again for joining us.
Great, Paula. Thank you so much for that. A big reminder for everybody who has attended today, we will be sending a copy of the slides and the recorded presentation to you via email, so do be checking your email for that in the coming days. A big thank you to John and everybody at Trinseo for the great presentation, and I thank you all for attending, and have a great rest of the day.